friends, in the previous slide, we discussed what is modulation. Now, in this video, we were discussing types of modulation and amplitude modulation. We are going to discuss. Okay. So first, the types of modulation, we're having two types of modulation. One is continuous wave modulation and another is pulse modulation. In continuous wave modulation, again subclassified into two varieties. One is amplitude modulation and another one is angle modulation. Amplitude and angle modulation. Again, angle modulation classified as frequency modulation and phase modulation. Already in the previous slide, we discussed what is amplitude modulation, what is frequency modulation, what is phase modulation. Why? These are the parameters of an analog signal: amplitude, frequency, and phase. If any characteristic is varied in accordance with the message signal, we can call it as such type of modulation. Okay. When coming to the pulse modulation, again pulse modulation is subclassified into analog and digital modulation. In analog, we're having three variants. One is PAM, pulse amplitude modulation. Another is pulse width modulation, and third one is PPM, pulse position modulation. So this is come under kind of analog modulation. So in the analog communication subject, we are going to know about these 6 modulations. One is amplitude modulation, frequency modulation, phase modulation, and PAM, PWM, and PPM. So these 6 modulations are going to learn in this analog communication. And coming to the digital modulation, that is pulse code modulation. The first modulation is PCM, and there is delta modulation. So these are the varieties of modulations. Okay. So first, what is the amplitude modulation? If the amplitude of the high frequency carrier wave is varied in accordance with the instantaneous amplitude of the message signal or modulating signal, such technique we can call as amplitude modulation. If the angle of the carrier wave is varied in accordance with the instantaneous value of the modulating signal, then such technique is called as angle modulation. So this angle modulation is further divided into frequency and phase modulation. Okay. So already we discussed what is modulation. Modulation, I am saying simply, that is superimposing the message signal on a high frequency carrier signal. You can call it as modulation. But technically, the instantaneous value of the carrier signal is varied in accordance with the instantaneous value of the message signal. That can be called as modulation. Okay. So now, frequency modulation. If the frequency of the carrier wave is varied in accordance with the instantaneous value of the modulating signal, then we can call it as frequency modulation. Already discussed. Analog signal having 3 characteristics. One is amplitude, frequency, phase. So any one of the characteristic of the carrier wave is varied in accordance with the instantaneous value of the message signal, we can call as that name of that modulation. If amplitude is varied, we can call as amplitude modulation. If frequency is varied, we can call it frequency modulation. A phase is varied of the carrier signal in accordance with the instantaneous value of the message signal. Then we can call as phase modulation. Okay. So now we are going to dealing the amplitude modulation. So what is amplitude modulation? The amplitude of the carrier signal varies in accordance with the instantaneous value of the modulating signal or message signal is called as amplitude modulation. That is our amplitude modulation. Okay. So for any modulation, we require two signals. One is message signal and another is the carrier signal. Message signal is a low frequency signal, whereas the carrier is a high frequency signal. Okay. So this picture which give a good idea about this amplitude modulation. In the first figure, that is a message signal, you can see is a low frequency message signal. Low frequency message signal. And below one is the carrier signal. It is a high frequency carrier signal. After modulation, we get that amplitude modulated signal. So that we can see. The below figure is the amplitude modulated signal. Here, what is amplitude modulation? The amplitude of the carrier signal is varied in accordance with the instantaneous value of the message signal. Is called as amplitude modulation. Okay. So now we are going to a representation of waves in time domain. So we required modulating signal. This is nothing but message signal. Is m of t. M of t is equal to am cos 2 pi fm t. So am is the amplitude. Message signal amplitude or modulating signal amplitude. Fm is the frequency of the modulating signal. And the carrier. Why? For the modulation process, we require two signals. One is modulating and another one is the carrier signal. So the carrier signal is C of t, which is equal to AC cos 2 pi fct. Why? Here all are going to sinusoidal signals. This is analog signal. So we use that cost functions. Okay. So where AM and AC are the amplitude of modulating and the carrier signal respectively. FM and FC are the frequency of the modulating signal and the carrier signal respectively. So after applying these two, one is a modulating signal and another is a carrier signal, we get the result is a modulated signal. The modulated signal is represented as S of t. S of t is the modulated signal. So here which modulate is done? Amplitude modulated. So S of t is the amplitude modulated wave, which is equal to AC of 1 plus Ka m of t cos 2 pi fct. That is the modulated signal, where Ka is the amplitude sensitivity of the modulator. Already you know m of t. M of t is am cos 2 pi fm t. Now we are going to substitute m of t in s of t. In the first equation, AC of 1 plus Ka m of t. So that m of t is the message signal or modulating signal. So we are going to substitute in that m of t the given equation. Okay. So the carrier wave being modulated, the modulated level is calculated, we can call it as modulation index or modulation depth. Modulation depth. Let your mu is equal to Ka AM. When you check that the modulated signal S of t is equal to AC of 1 plus Ka AM cos 2 pi Fm of t cos 2 pi Fct. That is our previous equation what you write. So in the place Ka AM we use mu. That mu is the modulation index or modulation depth. So this is our signal. One is a modulator, modulating signal, and another is a carrier. You applied those two, modulating and carrier, you get amplitude modulation. Here the amplitude is varied in accordance with that message signal. The carrier signal is varied in accordance with the message signal, that is amplitude. A frequency is varied, we can call it as frequency modulation. So in this picture we can see those two modulations. One is amplitude modulation and frequency modulation. Okay. So in the frequency domain description, S of t. What is S of t? S of t is the amplitude modulated wave. It is in time domain. T represents time domain. So we convert this time domain into frequency domain. So what you get? S of t is equal to AC of 1 plus Ka M of t, which is multiplied with cos 2 pi Fct. So I'm going to multiply this cos 2 pi Fct into inner of the two brackets. Then we get AC cos 2 pi Fct plus AC Ka M of t cos 2 pi Fct. So that is our modulated signal, amplitude modulated wave. So we are going to convert this amplitude modulated wave into frequency domain. How? We're taking Fourier transform on both sides. Now we are applying Fourier transform. Okay. So after applying the Fourier transform on both sides, S of t is converted as S of f. In previous it is in time domain. After applying Fourier transform is converted into frequency domain. So S of f, which is equal to AC. Here cos 2 pi Fct. So the Fourier transform of cos 2 pi Fct we taken as delta of f minus fc. Actually get 1 by 2 delta of f minus fc plus delta of f plus fc. That is get for cos 2 pi Fct Fourier transform. Okay. And the next one we have summation plus AC Ka M of t. Again here M of t is there and cos 2 pi Fct. So for applying Fourier transform for the second one, AC Ka are the constants, so put outside. So that is AC Ka divided by 2. So here actually 1 by 2 of M of f minus fc plus M of f plus fc. That is the actual Fourier transform what to apply for the second one. Okay. So now the total S of t, that is amplitude modulated wave. After applying Fourier transform, we get S of f, which is equal to AC by 2 of delta of f minus fc plus delta of f plus fc plus AC Ka A by 2 of M of f minus fc plus M of f plus fc. That is after applying Fourier transform, that amplitude modulated signal is converted into like this. So here you can see the spectrum of AM. So in the first figure, that is M of f, that is a message signal. Okay. So M of t is the time domain message signal. M of f we convert it into frequency domain. That M of t is converted into M of f. And Fm plus 0, right side having Fm, left side having minus Fm. So that is the band of that message signal. FM is the message signal frequency or modulating signal frequency. Okay. So after applying, uh, after modulation process, we get the amplitude modulated signal, that is S of t. So for S of t, in the previous slide, we given Fourier transform. So S of t converted into S of f. So Fc is the carrier frequency. So around the carrier frequency, this message signal is there. Okay. So the blue indicates upper sideband and brown indicates the lower sideband of that AM wave spectrum. Okay. So the transmission bandwidth. So what is the transmission bandwidth? The difference between USB means upper sideband and lower sideband frequencies defines the transmission bandwidth. So simply BT, which is equal to F of USB minus F of LSB, already shown in the previous figure. So USB is FC plus FM minus of FC minus FM. So finally, the transmission bandwidth, which is equal to 2 FM for the amplitude signal. Now the modulation index. The ratio of changes in amplitude of modulated signal to the amplitude of carrier wave is known as modulation index or modulation factor. So that is equal to mu, which is equal to Ka AM. Ka is the amplitude sensitivity of the modulator and AM is the amplitude of the modulating signal. So already having a carrier signal, that is AC. Amplitude of carrier is AC. So if AM is greater than AC, the distortion is introduced into the system. So for proper modulation, AM less than AC. The amplitude of the message signal must be less than that of the carrier amplitude. Okay. Now the transmission efficiency. So eta is equal to power of USB and power of LSB divided by power of transmitter. That means efficiency would take in the total power, that is we are adding both sidebands, upper sideband and lower sideband. That is the formula for efficiency. And PT is transmit power, which is equal to PC of 1 plus mu square by 2, where PC is the carrier power. And power of USB and power of LSB both are equal, that is mu square AC square by 8. Okay. So you could substitute the upper sideband and lower sideband and PT, you get this one. So finally, efficiency is equal to mu square by mu square plus 2. After solving this equation, we get that one. So since PC carrier power is AC square by 2. So under modulation, if mu less than 1, we can call it as under modulated. So under modulated signal is like that. That is over modulated. When mu greater than 1, you can call it as over modulated. So over modulated signal is like that. And perfect modulation, that is mu is equal to 1, then you get perfect modulation amplitude signal. So our duty is mu must be equal to 1. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.